as triangle number 3. So notice for triangle number 3, look for the short side here, and then medium, and then large. So start on the short on the bottom, and then medium and large going counterclockwise. And so take your numbers of 24, 26, and 20, and give me the smallest number on the bottom, give me the medium number on the right side, and then give me the longest number on the left side. And then do that same thing with the second triangle. So I'm going to start you off. Maybe you're wondering, I don't know what to do. So let me tell you that this one, see, out of 20, 24, and 26, let me hold your hand a little bit there. And this one's going to be 20. And then which one is the medium one, right? Which one is the next largest one? It's going to be that number. And then which is the longest one? It's going to be that number. Okay, so now that you have that, then do the same thing with number 2, with small, medium, and large. And then notice what I've done. Now let's compare the short sides between triangles 1 and triangle 2. And let's put triangle 1 up on top and triangle 2 underneath it. So what is the shortest side of triangle 1? It is 20. And what is the shortest side of triangle 3? It's going to be the side that's down here, but even just looking up here, I can see that it's 24. So 20 over 24 is the ratio of the shortest sides for triangles 1 over triangle 2. And I can reduce that by dividing top and bottom by 4. And if I do, I get a ratio of 5 over 6. So now you do the same thing. Well, I've started to do the same thing for the medium side. Okay, so which is the medium side here? It's 24 for triangle 1. And for triangle 2, the medium side is going to be 30. So that's why I put 20. Did I say 21? I don't know. Oh no, I said 24 for triangle 1. There's. So you have 24 over 30. See, 24 over, where is it? Over 30. And it'll be these two sides that correspond to each other once you get your numbers on there. And then reduce this 24 over 30 and see if you get the same ratio. If it is not the same ratio, well, you can stop right there, because in order for these two triangles to be similar, all three of these pair of sides need to have the same ratio. But if it is the same ratio for the medium, then make sure that you also do the ratio for the long. Okay, once you've done that, then compare triangles 2 and 3 and see if the ratio of the shortest, medium, and longest are the same ratio, and then do the same thing with triangles 1 and 3. Okay, go ahead and pause the video and do that. So question number 2 now. The shortest side of a triangle similar to triangle RST, so they're talking about this guy, RST up here, is 12 units. Okay, the shortest side is 12 units. Find the other side lengths for or of the triangle. Okay, so remember we did this where the shortest side is on the bottom, and then medium and large. So your shortest side should be here, and then medium and large. And now they're telling us that we have this new triangle where the shortest side, that these two are similar to each other. So I've drawn a similar triangle here. I don't know whether it's supposed to be smaller or bigger, but it says that the smallest side is 12. So to put it in the same orientation, let's put that on the bottom. And in fact, the smallest side up here is 24, so you should have the number 24 there. And so yeah, this other one is smaller. So now they want us to find the other lengths. So let's call this guy X over here, and call that dude Y. And now you're doing the same thing that we did, very similar, to use the same word in a similar way, but different way. Remember how back here in 6.1, when we wanted to find the value of X, we would start out with X up on the top left. This is a proportion, remember that? And so we start out with a fraction bar, equals, and fraction bar, and let's put x up in the top left here. And so we'd say, okay, what side is corresponding to the x? In this case, it'd be 4 over there. And then let's pick another pair of sides that we do know the lengths for. And so over here, what you're doing is you would start out with saying x and then fraction bar equals fraction bar. So what side corresponds to x? So whatever this number is up here, that's the number you'll put underneath. And then what pair of sides do you know the numbers for? And that's this one. So you know 12, and so 12 would go up on top, and then whatever number that you put here for the smallest side, that would go underneath. And then you'd have your proportion, and you will be able to cross multiply that proportion and then solve it for x. And then do the same thing for y to be able to solve for the unknown side length there. So go ahead and pause the video and do that, and you can go back to section 6.1 if you need to. Now let's do our last two, and I think this is pretty easy. Determine whether the triangles are similar and write out a similarity statement. In fact, back here with number 1, they did also ask us to write a similarity statement. So let me explain what that is talking about. So remember, in order for these to be similar, I need to use one of these 3 theorems to prove that they are similar. And so what do I have here? As far as angles, what do I know? Well, I do know that I have one pair of angles. They're both right angles, therefore they're both 90 degrees, therefore they're both congruent with each other. So I have one pair of angles that are congruent with each other. But what else do I have? Well, let's see if I have a pair of sides. Now, do these sides have to be congruent? No, not congruent, but as we said, proportional. In fact, I should probably write that up here. Proportional. So these sides here are have the same proportion as we see down here. In fact, let's go ahead and put an arrow down here. I'm going to do this like that, I guess. Yeah. So these are stating that the ratios need to be equal with each other. In other words, the sides, corresponding sides, are proportional. So back down here, what you need to do is create a proportion. So I would say 24 over 18, and does that equal, we're asking the question, does that equal 28 over 21? So see what I'm doing? I'm going from left to right. 24 over 18, does that equal 28 over 21? And if so, then these two sides, these two pairs of sides, have the same ratio, and you would therefore be able to use your side angle side similarity to prove that these two triangles are similar. And then if that is the case, then write out a similarity. Let me put that a little bit higher here so it doesn't get lost if I make a copy of this. So write out a similarity statement. So let me do SRT. Okay, so triangle SRT is similar to triangle what? If these two are, if you determine they are, then tell me what the other 3 letters are here. And it needs to be in the same corresponding order that SRT is. Okay, that's what they mean by similarity statement, and it needs to be in the correct order. So go ahead and pause the video and do that. And now our last question, question number 4, and this is funky. This is really a cool geometry problem. Here we have, and let's call this a right triangle. I know they didn't say it here, but let's assume that it is a right triangle, because we're going to do a lot of these that are right triangles. And they're asking to see if the question is, how many triangles are there here? And yes, there's one on the big outside, there's also one on the left side, and there's a third one on the right side. So let's look at this big triangle, And then let's break this medium triangle on the left-hand side off to the left here and put this in the same orientation as this larger one. And then let's take the small right triangle and break it off and put that also in the same orientation. So I've already gone and put the letters here for you so that they will align, just to make it clear for you. And then you put the numbers that are appropriate, put those numbers around here. And then do your similarity, calculate your similarities, or calculate your ratios of the sides. So in essence, with these three triangles, I'm asking you to do just like we have here with this table. Do what you can. Sorry, there's not a whole lot of room there. But first compare, if you want to, compare these two small ones together. And then if you have space, compare the medium with the big one, and then the small one with the big one. Okay? And see if you can determine whether or not any of these three pairs of triangles are similar with each other. Okay, I hope that was helpful to you, and we will review and go through this stuff in class, of course. May the Lord bless you, and I look forward to seeing you in class.